Hello everybody. So today let us discuss about a question that was asked in GATE 1991. The question is the maximum value of Poisson's ratio for an elastic material is, and the options given are 0.25, 0.5, 0.75 and 1. Let us see what is Poisson's ratio. Poisson's ratio is defined as the ratio of lateral strain to linear strain within elastic limit. Now, we see that it is a ratio. What is lateral strain and what is linear strain? Suppose you consider a two-dimensional object and see this has a longitudinal dimension. We will take this as length and a lateral dimension, a smaller dimension, we take it as B. If we are giving a tensile stress along the longitudinal direction, we are giving a tensile stress of P along the longitudinal direction. The larger dimension is taken as the longitudinal direction and the shorter direction is taken as lateral direction. So when we are applying tensile force P, this L, the length of this object will be extended by a small length delta L, and this B will be reduced by delta B. So delta B is the reduced length and delta L is the increased length. Now we know what is strain. So strain is the change in dimension by original dimension. So strain along L, along the longitudinal direction is delta L by L, that is change in dimension along the length divided by the original length. Similarly, the strain in the shorter direction is equal to delta B by B, change in dimension in the shorter direction divided by the total or the original dimension. Now, so our Poisson's ratio is equal to lateral strain by linear strain. So this is nothing but our Poisson's ratio will be equal to EB by EL. EB by EL. It is also represented by the symbol mu, or it is equal to 1 by m. Now, Poisson's ratio is a dimensionless quantity. Why it is a dimensionless quantity? Because both are strain. Strain is dimensionless. Poisson's ratio is also a dimensionless quantity. And what is the reason to determine the Poisson's ratio is, it is used to determine the deformation property of a material. And thus Poisson's ratio is same for tension and compression. Now let us see the Poisson's ratio for different materials. For concrete, the Poisson's ratio is 0.08 to 0.18, and since this Poisson's ratio is the lateral strain to linear strain, the value for Poisson's ratio is always less than 1 because the longitudinal strain is always greater than the lateral strain. That is why the Poisson's ratio is always less than 1. Now, Poisson's ratio for cast iron is 0.23 to 0.27. For mild steel, 0.25 to 0.33. For copper, it is 0.31 to 0.34. For aluminium, it is 0.32 to 0.36. For brass, it is 0.32 to 0.42. And for rubber, it is 0.45 to 0.5. So, the Poisson's ratio for concrete is lesser than cast iron. Cast iron is lesser than mild steel. Mild steel is lesser than copper. Copper is less than aluminium. Aluminium is lesser than brass, and brass is less than rubber. So, the value approximately starts from 0.1 and the maximum value is for rubber, and the value is equal to 0.5. Therefore, now you would have got the answer. See how you can easily remember is only aluminium and brass has the values, copper, aluminium and brass has the values approximately equal to 0.3. Then for rubber, the value is approximately equal to 0.45 to 0.5, and for all the other material, cast iron and mild steel, it is approximately 0.23 and 0.25, and for concrete it is very less, 0.08 to 0.18. Now, see, so the Poisson's ratio, the material with the least Poisson's ratio is concrete, and with the maximum Poisson's ratio is rubber. Now we got the answer for our question, that is the maximum value of Poisson's ratio for an elastic material is 0.5. Thank you.